Okay, so again, so it's 1, 2, 3, 4, 5, 6, 7. We decided numbering going this way, and has a methyl coming off here. And so what you end up having 2-methyl, 5-methyl. So you put them both together, so it's 2,5-dimethyl. And then here's your parent chain, 3-heptane, heptene. Right, this example. All right, so find the longest chain. So longest chain is going to be this, and we're going to be going this direction. It comes off number 1. So we got 1, 2, 3, 4, 5, 6, 7, 8. So it's be a 1 octene. Okay, so this double bond comes after number 1, and it has an ethyl, methyl, and an ethyl coming off at looks like 4 and 6. So 4 and then 6. Okay, so here's the longest chain, octane, octene, and then number changes. So we're going left to right. Comes off number 1, octene. Then there's methyl coming off of here, ethyl coming off here, and so you'll have 6-ethyl, 4-methyl, 1-octene. Now, one of the things about this, okay, is that if we had a single bond here instead of a double bond, then you would have actually numbered it from left to right, okay, because that would give smaller numbers. That would make this 3-ethyl and 5-methyl. So the double bond here determines the direction, not the smallest numbering of these side groups. Okay. Okay, now we're going to talk about geometric isomers, and this might be a little confusing. And in the worksheets, I'll help you work through it, and I'll describe it now, but hopefully more clarification will come through worksheet. And it's important where they put the double bond really restricts things. That's what this is all about. Okay, and we're gonna have things called trans and cis isomers across and same side. And probably have heard of cis and trans. This is where they originally came from, actually. Uh, this means same side. This means different side, and you'll see what that means and right now. Okay. All right. So before we go to that, let's look at butane, which is an alkane. And so here, so I drew it like this. Okay, like this right here. And you have the double bond. And I also do it like this. And then I ask you, are these two structures the same? Well, yes, they are, because these single bonds, what you can do is you can rotate around those bonds. So what I can do is I can flip this guy by twisting this. I can turn this carbon so that it's down here. So these two guys are identical. So these two structures are identical. Right, how about this guy here? So so this is 2-butene. Okay, 1, 2, 3, 4. 1, 2, 3, 4. Right. Okay. Now, so they both have double bond coming off number 2. But are they the same? Are different? They are different. And the reason why they're different is that this guy here is stiff and you can't rotate around it. So I can't twist to turn this guy this way. So these two structures are different. These are two different structures. They're both 2-butene. Okay, but they are not the same. Okay, so what I'm going to do is I have to come up with the name of both of these. Okay, because these are different molecules. They behave differently. So the way we're going to name them is we're going to name them according to these two groups. So you have the double bond, and what you kind of do is you draw a a perpendicular line through it, and then you look at the opposite side and see if it's across from it, on the same side, so same side, or on different sides. Okay, if they're on the same side, this is called cis. Okay, if they're on different sides of the double bond, then it's going to be trans. And we would name that. So this would be cis 2-butene, and this would be trans butene. Okay, and this is a three-dimensional showing of them. So you can't twist on this double bonds. This double bond here locks it in place where you can't twist this guy up here. If you remove that bond right there, you can twist it up here. Okay, and again, if you draw a line through here, and then you look at the carbons on the opposite sides, if they're on the same same side of the double bond, then they're cis. If they're on the opposite side of the double bond, they're called trans. All right. Okay, so now let's go into alkynes. Alkynes have triple bonds. And that's also going to restrict the movement. Now, let's take a look at this guy here. This is the simplest alkyne you can have. This is called ethine. Okay, notice this is that if it had one bond, it'd be ethane. If it had just a double bond, it'd be ethene. Okay. Now, what's the shape around this molecule here? Okay, so around this carbon here, well, it has two things attached to it. No lone pairs. This is linear, and this carbon here is also linear. Okay, so there it is again. Ethine is also known as acetylene. You may have heard of acetylene. It's used in welding. Right. Then you can have propyne, and then butane. Okay. Again, same as with double bonds. You need to tell where the triple bond comes off of, and then you could have hexane. And we're not going to deal with molecules that have any more than one double or triple bond. So 2-butane. So this is butane. Here's 1 hexane. So going this direction from right to left, it puts the triple bond after number 1. You always want to have smallest numbers, and the numbering will be the same as before, as like we did alkenes. And let's do 1 here. So what you do is you find the longest chain. So 1, 2, 3, 4, 5, 6, 7. If you want this way as well, you get the same. So this is going to be 1, 2, 3, 4, 5, 6, 7. So actually not. This is 1, 2, 3, 4, 5, 6, 7, 8. So actually the direction's like that. Sorry. So so it's an octine, and the triple bond comes off. If we did directions the best for giving the smallest numbers, going from right to left. So this is going to be a 2-octine. And then what it has is it has 2 methyls coming off of it. Okay. So 2-octine. So there's your octine coming off of number 2. And then you have a methyl coming off of number 6. And it also comes off of 6 here. So it comes off in the same carbon. So again, as we showed before, you have to tell, so it's going to be a dimethyl. And again, you have to tell that both of them come off of number 6. So it's going to be 2-dimethyl 2-octine. All right, so that has to do with, that's all you have to do with the alkenes and alkynes. You go through the same process. You find the longest chain, and then name it according to the longest chain. The numbering is determined by the double bond or triple bond, and then you label the side groups or alkyls, and then number according to what's already the chain is already numbered, and then you put it all together. Okay, now we're going to go over a couple reactions that you have to know, and these are important. And like I said, there's only a few chemical reactions you have to know, and there's two of them here that you're going to have to be able to do, actually show. You won't have to show a combustion reaction, you just have to tell me what happens. Take a hydrocarbon, combine it with oxygen, produces carbon dioxide, and water, and energy. These ones you have to be more specific. And addition means is that you're going to add something to your alkene. And there's two types. There's what is called hydrogenation. In this case, you're adding hydrogen. So you're adding hydrogen to the alkene. The other type will sound a lot like it, but pay attention to the words. So hydrogenation. Okay. All right, so let's show you what you have to do. All right, so what you have is you have your alkene. I know there's kind of askew here, but these hydrogens are attached to this carbon here. Okay, and then what you do is you add hydrogen in the presence of a catalyst. And what happens is the double bond goes away and is replaced by hydrogens. And so you get this here. And so what you've done is you've added the hydrogens. Okay, so right. So you replace the double bond with two hydrogens. Okay, the other type is called hydration, and you've heard of getting hydrated. It means takes on water. Okay, and so what we're going to do is we're going to add water to a alkene. The water is going to come apart. It's going to add an H to one of the carbon, and it's going to add an OH to another carbon. You don't have to know this, but typically you have to add acid to help the reaction take place. So let's go through a version of this. So what you do is you take, here's your alkene. So this is ethene, and you're going to take water, and you can write water as HOH. Okay, sometimes I do that. And then what happens is that the H will go to one of the carbons, and the OH will go to the other carbon. And it doesn't matter which one now, but they will do that. And so the double bond goes away, and you end up with a hydrated alkene. Okay. So in the previous case, for hydrogenation, let's see, right, hydrogenation. What you're doing is you're taking a unsaturated hydrocarbon and you're making a saturated hydrocarbon. Okay, so okay, we'll see that again when we talk about lipids. Okay, in this guy, hydration, what we're doing is we're taking an alkene and we're making what we're going to learn in the next set of material, what is called an alcohol. Okay. All right. So hydration is hydrogenation is when you add hydrogens across the double bond, and hydration is when you add water across the double bond.